Hi, my name is Amit Nandi. I work with Prolim. We are going to discuss about why simulation is needed today. What are the benefits out of it? Let's discuss this. If you look at any design process, it starts with the concept design followed by detailed designing, validation, and then finally the production. In concept design, we convert our ideas into the concept. In detailed design, we model the components, subassemblies, and entire assembly by using 3D CAD platform. And then we submit the design to the validation team, wherein they will check the performance of the design and compare it with the expected results. If the expectation is not met, then again the modification will be done in the design and then they will revalidate it. This process goes on until the uh, performance of the design is met. Once the performance is met, then we will release it for the production. If you look at any examples like this, right, these are the simple examples where we design these structures. Once the design is done, then we'll have to validate it, right? So instead of modeling the entire design, what we do is we can just represent these all scenarios with the help of our cantilever beam. So you might have studied the cantilever beam in your engineering uh, course, right? So if you look at this cantilever beam, the one end is fixed and the other end is uh, the load is applied on the other end. So here we are going to measure what is the deflection we are going to get and what are the stresses. So there are two approaches to solve this particular problem. So first approach is using the formula which is readily available with us, that is the deflection formula or the stress formula. The second approach is the testing approach, wherein we manufacture the beam and then we exactly represent the working condition and then we'll apply the load and then we are going to record the results, that is deflection results or stress results. If you compare these two approaches, both these approaches are 100% accurate in terms of the results. But the problem comes when we take our real life systems. Let's take an example of engine of any vehicle. So this is not so simple as the cantilever beam, right? And if you look at the landing gear mechanism also, there are so many physics involved into it. It may be control systems or it may be the mechanical systems. And then hull of the shift. Again, it is going to, you know, work with the fluid in the sea or in any domain, right? So these are all typical applications which we really deal with, not like the cantilever beam. So how do we solve these kind of problems? Again, if we use the same approach of validating by using the formula, but for these kind of applications, this formula don't hold good. So we don't even have the set of equations to solve these kind of problems as well. So the first approach is ruled out. The second approach is testing. Still it holds good, but the problem with the testing is it consumes a lot of money and a lot of time in validating the systems. So we are just talking about the subsystems of the system. If you look at the system wise, it may be the automobile system or aerospace system or satellite system or marine system or heavy engineering systems or heavy machineries or appliance system which we deal with in day-to-day life, that is fridges or washing machines, right? How can we validate these systems? How can we check the performance of these systems? This is the big question now. That's where the third approach comes in, that is computer-based simulation. So if you compare this computer-based simulation with the first and second approach, still on the accuracy side, it is somewhere between 80 to 90%. But this does not consume a lot of time and a lot of money. In turn, it increases the performance in addition to the reduction of cost and time. So, computer-based simulation will help you to model any kind of physics, any kind of systems, and any kind of situations. So, this will not only help you to check the or predict the performance, it will also help you to optimize it. It will also help you to, you know, change the performance with respect to different designs, with respect to different materials, just to reduce the overall cost of the product. Let's take an example of a chair. Let's say you want to manufacture a chair, right? So what you do is first you will come up with a concept, that is, this is how my chair should be and this is how my chair should look like. Once the design is done, then you have to validate the design. So you are going to validate it with respect to the load carrying capacity. So let's say, what if a person weighing 100 kg sits on it, whether it is going to break or not, or whether it is going to sustain that load or whether it is going to break. What if a person of 150 kg sits on it, whether it is going to sustain that load of 150 kg or it is going to break. So that's what the validation does, right? But if you use the first approach anyways is ruled out because you don't have set of equations to solve or formulas. The second approach, that is testing, which consumes a lot of time and a lot of money into it. So of course we can use the third approach of modeling the chair and representing the person sitting on the chair in a virtual environment. This is exactly how it looks like when you use the virtual or computer based simulation modeling techniques. So the chair is represented by the number of elements and nodes, and a person sitting on a chair is represented by a node with the person weight, and that is being connected to the chair. So once we are done with the modeling part, then we will define the loading conditions and constraints. So how exactly it is going to uh, stay in the real condition. So once we set up the model, then we will run it, and then we will get the results of deflections, deformations, displacements, and also the stress counters like this. So by looking at these results, it will not only give you the performance or load carrying capacity of this chair, it will also help you to where exactly you need to modify. So based on these results, you are going to tweak that particular feature or particular dimension and then do the modification. So once the modification is done, then you can quickly resolve it again with the same set of boundary conditions, and then you are going to get the results with the modified design. So now you can also check with the alternative materials as well. So let's say you have modeled this with steel, so you can model it with aluminum and then check the performance, and then you can check with various materials as well, so that you can cut down the cost of the product. So this is how best-in-class companies enjoy a minimum of 6% decrease in the product cost. So this is being stated by one of the surveying company called Aberdeen Group. Cost saving strategies for engineering. Let's look at the comparison between the traditional process and the process with the simulation, that is design process and design process with simulation. This will give you the benefit of not only saving the time and also uh, the reduction in the cost of the product, and validation will also save the number of prototypes to be tested. So here uh, one thing needs to be clear, that the validation through simulation is not a replacement of testing. I repeat, simulation is not a replacement of testing. So once the simulation is done, then you have to manufacture one or two prototypes and then test it in the real life conditions. So with the implementation of simulation in your design process will increase your design time, but if you look at the overall time of the process, it is still on the reduced side, right? So if you look at the real life complicated systems, starting from the left hand side, so it exactly show you how the system behaves. The second picture shows that how you can accurately predict the physics in virtual environment, and third picture talks about how you can model the humidity in the lighting system and other environmental conditions as well, and what will be the effect on the thermal behavior and also the structural behavior. Last but not the least, that is how well you can optimize the design. So once the design is freezed, once the validation is freezed, then you can work on the optimizing the design to reduce the material consumption. So in the nutshell, the benefits of using computer-based simulation will reduce the total number of physical testing, so which reduces the overall development cost, uh, leading to the reduced product cost. So you are making your product cheaper compared to your competitor. And when it comes to the time, so you are still maintaining the speed of releasing the product to the market. And if you look at the return on investment, so you will very fastly realize the return on investment of this particular virtual testing platforms. So, best-in-class companies enjoy a 6% decrease in the overall product cost. That's what the survey says. The second thing is the failure analysis. Uh, this will give you the idea on how exactly the product is behaving. So, if it is failing before the expected life, then it will help you to improve the product performance, reliability, uh, and also you can reduce the costly reworks as well. So again, there is a benchmark which talks about best in class companies enjoy a 7% decrease in warranty costs. So without any investment, you are saving this much of cost in terms of your product development and also in terms of your repairs and recalls. Then comes the optimizing the design. So this will reduce the weight of the product and also the material consumption in it. You can also evaluate the performance with other cheaper materials as well. which will eventually result in minimum of 20 to 30% decrease in the overall material consumption and its cost. Last but not the least, that is performance uh, of the innovative designs and trade-off studies. So trade-off studies is nothing but you can evaluate a number of different designs within a stipulated time. So you can quickly modify the design, change the design, and then you can see how it is going to behave in the real condition. And not only the design, you can also change the different materials as well. So there is no end in the innovation. So you can innovate your products as much you can, but we have to keep the time and cost in mind while putting our efforts towards the innovation. So best in class companies enjoy increased MSQ, that is market share, market margin on sale, and market size is getting increased by doing all this virtual testing with the help of simulations. So the simulation being a key to success of any product of any organization. Here it comes the SimCenter portfolio, which is meant for the simulation only. Uh, SimCenter portfolio has three spokes in it, that is covering mainly on the system simulation and detailed simulation and then physical testing. So system simulation will help you to predict the performance of the multiphysics and multi-attribute system behavior during the concept design itself. And then the CA simulation will help you to predict the behavior and optimize the performance of the design in detail. And physical testing will help you to acquire the data from your testing activity to data acquisition systems. So this is how SimCenter portfolio can help you to uh, achieve success in both product as well as organization. Thank you so much for watching. If you have any queries, please feel free to reach out to me on 916-450-4590. Or you can also write to me on amit.nndi@prolim.com. Thank you so much. Have a nice day.